Thanks for that transition, Johannes. So that was a little bit of the why. Now we're going to talk in sort of more concrete terms about the how. So as Johannes mentioned, my name's Geoffrey. My sort of main gig is that I'm a PhD grad student actually at MIT, doing kind of research on new ways of doing computing. And my collaborator Nicholas and I had been thinking about local first for a while in these sort of abstract ways, and we were looking for a project to make all this stuff real, and that's how we found Johannes. And so we've been working together on this music app. And just to kind of set expectations a bit, I kind of want to, the feeling I have is that we've sort of been on this very strange journey into a weird jungle for a year or two, and I'm sort of like coming out of jungle to tell you, like, here's how it's going. I'm not necessarily telling you, like, you should go into the part of the jungle we've gone into and do it exactly this way, buy our product, whatever. It's some combination of, like, there's some really cool stuff here, and, you know, watch out, like, don't do it that way or whatever, right? So it's, you know, expect this less of pitch than more like a experience report, I guess. And so I'm gonna mostly try to just show you some demos of the stuff we've been building and show you a little bit of how it works in detail so you can get some flavor for it. I think in the time I have, I won't be able to cover all the details, and we'll talk about it afterwards and stuff, but I just want to give you a sense of what we've been up to. So the core problem we've been trying to really focus on is how do we achieve those developer benefits that Johannes mentioned with a local first architecture? So if you assume local first, what new capabilities does that unlock for simplifying how we build UIs? And the basic problem, you know, Johannes basically laid it out. Traditional apps have all these layers. We're used to all these things we have to do. Just adding one feature, it feels like you have to add code in all these different places, and it just feels complicated. And the basic premise of local first is what Johannes said. Let's just have our client, we have some local database, we have a UI. OK, seems simple so far based on this diagram, right? But then you start thinking about it, and if you're used to building in the three-tier architecture, there are all these questions that suddenly emerge. Like, OK, hold on. Before, we had these different ways of representing data. Like, we had Postgres back there, and then we have like JavaScript objects over here. And wait, which one are we supposed to use in this local database, right? It's not really obvious. There's a bunch of questions that emerge. You know, the data model, right? How do we represent data? What query language are we using? Like, are we using SQL? Are we using Prisma? Are we using like JavaScript functions? How does that stuff work? And then because we have these layers, the number of layers has changed. It's sort of unclear, wait, like which layers are responsible for which parts of what we used to do in the three-tier architecture. So I think there's actually quite a large design space, even once you decide on local first. These are questions that can have multiple answers. And so what we've done on the Riffle project is tried out a particular configuration of answers to these questions that we think is compelling. It's a little bit weird, but it leads to interesting things. So here's the basic idea. We want to really take advantage of having a local database. So we're going to try to really tightly couple our UI to the local database. And we're going to have this like very tight coupling that seems unusual if you're used to having a database far away. We want to get everything we can out of the localness of the database. Part of that is we can assume fast access to local data. So most apps have to deal with this sort of assumption that the data might take a while to get. But we know that the data is on our device. So if we can, what can we do with that assumption to gain as much simplicity in the mental model as possible? That's another goal. And more specifically, we decided, all right, the relational database model, probably most people here have used one. There are reasons that over time the industry has kind of settled on that as, I would say, the default storage format for backend data. You know, it's a very mature model. It's really versatile. You have schema constraints that help you avoid your data getting out of control. And we decided, all right, let's use that for our local client-side database. And the last piece is reactive queries. Let's really lean into reactivity of the sort that you're used to if you use a view framework like, you know, React.js. But let's have really good reactivity all the way through the stack with all of our data. These are kind of the goals we're shooting for. So what does that mean in practice? It's really quite simple. We have a relational database, right? You can do SQL queries on it to get data into your UI. If you want to do other kinds of queries that do like derived data, you just add more SQL queries to this mix. And then all the queries are reactive. So we shouldn't need to know when we want to pull the database for new data or whatever. We just want to write a SQL query, and then anytime the data in our database changes, it should auto-update the UI to keep our lives simple. Now, the last piece is this is local first, not local only. So we do need some way to get data to other clients. And I'm just going to kind of hand wave over that and say, somehow someone else is going to take care of that for you, right? So as a developer building the app, you worry about kind of this interface and don't really worry too much about the sync. That will happen somehow. And in fact, in this talk, I'm really not going to talk about the sync part that much, even though that's a really important part of local first. And the reasons are sort of, one, that there's actually a lot of really interesting stuff in this part, and two, that we honestly haven't really gotten very far on the sync part. So that's sort of a bit TBD. Cool. So I'll get to demos in a minute, but before I get to the demos, I want to give you a little more detail on kind of what exactly we've been building and a few of the cool things that we've been striving for. So what is Riffle? Riffle is a data management library that's sandwiched between a relational database and a view framework. So we chose React.js as our view, just because it's whatever the popular default. We chose SQLite as a database initially, because it's a relational database that was designed to be embedded in clients, and it's a very good, mature project. Recently, there's been a lot of work on getting SQLite running in the browser, which is a big deal for us because we want it running on device for a web app. OK, what does Riffle do then? Well, basically, Riffle is how you bind these two things together in a nice way to get your UI driven by a database. So it's just a few kind of React hooks that you can plop into components. And what it helps you set up is sort of like you can create these SQL queries that will automatically reactively update. You can do GraphQL queries as well. I'll talk a little bit more later about why we needed that. But again, this is all local GraphQL. There's no server or anything. And it's sort of like a spreadsheet that reactively updates and helps you manage your data. That's basically all it does. OK, so that's kind of what we're building. Now I want to tell you 3 kind of weird and interesting benefits that we've been shooting for with the project, and I'll get into the demos. So the first idea we have is this idea that managing all state in one system gives you a lot of benefits when you're building an app. And what I mean by managing all state in one system is that our goal is every single piece of state in your entire app goes into the database. So literally, React use state is not allowed. The screen that you're showing is a pure function of your database. That's the goal. Now, that might sound kind of weird. Why would you do that? There's a few reasons that are interesting. One reason is that you sort of get this very unified query model, where instead of having to reason about how state from different pieces fits together, you can write SQL queries that query over all the data together at once. Another reason is the moment you decide to share data across users that was previously thought of as UI state, and now it's suddenly become shared state, you don't have to totally move it to a different system. You can just flip a bit and say, OK, now share this stuff. Another benefit is you get persistence automatically for all UI state. That sounds like maybe not a big deal, but one of the things we found building these apps in Riffle is that there's a lot of UI state that web apps throw away that's actually really valuable. Things like which sub-tab were you on, or did you have the sidebar open, or how far down the page were you scrolled, or what was the essay you had written into the text area before you hit refresh. All these things, web apps don't really treat these with much respect. And if you give the developer by default a UI state library that persists everything, that actually is really nice for UX. So that's one weird benefit we're going for. The second idea is just that, figuring out data dependencies in a lot of apps is really complicated. And maybe if you just kind of have this graph of SQL queries that depend on each other, we can reason more easily about what the heck's going on. And I think we'll see some examples of how that plays out. One kind of view we have ultimately is that you can start to think of your entire app as this reactive DAG of queries, and that's all it is. The final benefit we've been going for is that fast reactive queries provide a clean mental model. And what I mean by that is I really believe that the reactivity models in our applications are needlessly complicated because we have a lot of data far away. A very common thing, for example, right, is that you'll load a new view in a UI, but you know that the data is not going to be there yet, or maybe it might not be there yet. And so you have to have a loading spinner that you're going to show while the data is coming in. And there's these sort of 2 steps to the process, right? And there's all these situations in apps that are caused by that fundamental issue of the data might be far away. But if the data is close by, you can just say, every time that anything happens, we're going to instantly update the entire view to be perfectly, completely and consistently updated within 16 milliseconds. And if you can pull that off, the kind of developer simplicity you get is ridiculous because you don't have to worry about all these different steps that are occurring. And of course, it's great for users because users, users who don't know how apps work would look at this and say, of course, just make apps update instantly every time, right? Why wouldn't you do that? It's hard, but I think this would be really nice. And so this is our goal with Riffle. And we haven't gotten all the way there in every case, but I'll show you some examples of where we think the local first architecture really helps you get there. OK, so enough talking. Let me show you some working software. Let's see. Cool. OK, so I'm going to show you 3 apps that use Riffle. We're going to sort of walk up the complexity ladder a bit. So I'll start with just To Do MVC. You've probably seen this app before. This is the typical thing, to-do list app, has filtering and so on. And here's a little debugger where we can see how it works in Riffle. So I have my database in my browser. It has my to-dos in it. You can see, if I add a new to-do, it shows up immediately in that relational database. One weird thing, though, is that in addition to the to-dos, I also have my UI state, right? So here is my UI state table. It has a little box here that stores the state of this text area. And that's in the database. So if I refresh, of course, it's still there, right? Very simple schema here. There's not too much complicated state, but you're already getting a few interesting benefits from having everything in a database. Another thing I'll show, let me fix the color scheme. OK, so in this debugger, I can also see how the app works. And it's really just SQL queries. So you can see here, this is the query that's running to load this filtered view. And if I switch the filter, it's just setting up a new query that has a different filter predicate on it, right? So you can see that query is changing as I change this. When I showed this demo to someone who doesn't build web apps, and he said, oh, yeah, isn't that just how apps work? You edit the SQL query, and it redoes it in the browser or whatever. And I was like, well, not really. It's actually usually a little more complicated than that. And to me, it feels like this is kind of, I don't know. It feels very nice in how it should feel when the system works like this. I guess one other thing I'll show you is that I also get a live REPL to my database in the debugger, of course. So this is just querying. I don't know. I can run queries and get live reactive results on them and stuff. And I use this often to prototype. So I can prototype a little SQL query, and then I just pull it into my app, and it's running there. So we see there's kind of these interesting benefits from having this live reactive database in our app. I'm not going to show you too much code now, because I don't really have time to explain it all. But just to give you a tiny flavor of how this app works. This is my React component that shows the data. And you can roughly see there's a SQL query in there that I've written. There's some other stuff here that's adding in the filter dynamically and so on. But the part that I want to emphasize is just I have a React hook. I pass in a SQL query, and it runs it reactively. That's the basic idea. All right. Now I want to ratchet up a little more to kind of a slightly less trivial example to show you a bit more real data schema and so on. So this is an app. I made this app a month ago, and it wasn't actually supposed to be part of the Riffle project. I was doing it for something else I was working on. It's not that important what it does. It's a tutoring app that students can use to have an AI help them learn stuff. And the original plan was I was going to build it with the typical 3-tier stack. But then I started thinking about, oh man, getting even to a deployed prototype thing is just going to be so annoying. And so I decided to build it in Riffle. And we can, again, kind of see, here's a little bit more. There's a few more tables here. But it's the same sort of structure. We have all the questions that are being asked of students. are in these tables, and there's groups of questions and stuff. We store like which, here you're seeing this changes as I select stuff because which question am I on right now is saved in the database. So again, if I reload, it remembers where I was and so on. Even like, I guess, this text box of what I was in the middle of typing is saved. And yeah, there's basically just a relational schema here driving this whole app. I was able to deploy this as an entirely static app and just give it to people, and they can try it, and they have local persistence, right? In this case, there hasn't even been any use case yet for syncing or sharing data to a server or anything, so we haven't even needed to build that at all. All right. So those were two small apps. Here is a much more substantial app. So this is Overtone. Yeah. This is the application that Johannes has been primarily in charge of developing. All credit for the app looking awesome and stuff all goes to him. I just cause weird problems with data layers. But so let's see. What is let me reload this actually. So what does this app do? Essentially, you can log into this and authenticate with Spotify and SoundCloud, and it will slurp up the metadata for your streaming collections into your local app. And then you can navigate your collection, see what's in your playlist and stuff, and then you can play the music on your device. The music itself streams through the streaming providers for now, because that's the only way to play music from Spotify. But there is a vision of over time making this app more and more sort of empowering for people in terms of actually having your music and owning your collection and so on. Some of the things the app does, if I'm authed properly into Spotify, yeah, it should, play your music, obviously. It has like really nice search, so I can just like search for stuff and instantly navigate my library. One thing you're hopefully noticing is that it's pretty fast. So a big frustration with the Spotify desktop client is, I don't know if there are any Spotify users here, but it just seems to get like slower and slower and slower all the time and just more bogged down with stuff. And something we really target in this app is having it be a fast, serious tool for people who actually care about music. Like if music is a big part of your life and you're trying to look through your music all the time, it's annoying when it takes like 1 second for any page to load, right? So having a predictably fast tool is a big goal for this app. Let's see, is there anything else, other features I've forgotten, Johannes? Anything else you wanted to mention here?
This is early, but like we have things like Command F search or just like, joining between different music services.
Huh?
So I guess there's potentially Command F search.
Yeah, I don't know why that didn't work. Okay.
It's an early prototype.
It worked this morning. Yeah. So yeah, I think you get the basic idea of...
Maybe show some of the development workflows.
Oh yeah. So there's also some really neat development workflows we can get with having like a local database. One thing I can do is just download the database. And this is a tremendously interesting tool to have for debugging. I can send this, so I'll show you what's in that file.
There's this a little debug overlay that I use on a daily basis to know hey, why is search broken? I can now download the database, inspect the database, and send over the database to Geoffrey, and Geoffrey says, aha, let me import the database into my app, and then Geoffrey sees exactly what I was seeing.
Yeah, one really interesting thing about having the entire app state in the database is that it's completely reproducible. Once I import this file, I'll be looking at exactly, the screen will always show me what Johannes saw.
Including scroll, state, etc.
Yeah. And so that's a really neat tool for getting visibility into what's going on. OK, I think that's all I'm going to show for... Sorry, was there a question? Or no? Okay.
Just saying that would be a good demo.
Oh, yeah, like loading in the file or something? Yeah. Next time. I think that's all the development. Yeah, there's other... yeah, that's probably the main thing. OK, so that's sort of like a brief glimpse at what the app does. Now I just wanted to give kind of a few reflections on what are the things that we think work really well and what are the frustrating challenges, I guess, that we've had to deal with. OK, first thing, fast reactivity. the goal that I mentioned earlier, it's really, really hard to get, especially in the browser. If you play video games ever, I think there's a culture and sort of a tech stack expectation that 60 frames per second smooth is a good goal to have. And if you shot the gun in the video game or jumped or whatever, and it took like 300 milliseconds for anything to happen, that would be a ridiculous expectation, or a ridiculous state of affairs. And yet in the web world, I think because things started from such a different place, you often will hear, oh man, your app loaded in like under 1,000 milliseconds. That's awesome. Or like 100 milliseconds-ish for responding to an interaction is like totally fine, right? That's 10 frames per second. And so something we found is that there's just like a cultural mismatch there that is often difficult to deal with. You can make progress if you know what you're doing, but it's not easy. I'm not going to go into the total nitty-gritty, but some of the things that we're doing architecturally that have been important decisions to get us to the demos you just saw. So we currently run our database in our UI thread in the browser. So it's running synchronously in the main thread. When we first were deciding to do this, it seemed like a really bad idea, and I was trying to convince Johannes, it'll be okay. I trust me, it'll work. And then 3 months later, I was like, oh no, what have I done? And honestly, to this day, I'm not even quite sure if it's the right decision or not. But the reason we did it is that to get a synchronous interface to a database like SQLite in the browser, the only way to do it is to load the database into memory and query it in your UI thread. You can't do I/O. Synchronous programming does solve a lot of complexity issues, like just getting rid of async immediately kills a whole host of things you have to think about. And so having synchronous interfaces we found is really, really nice. It's just a little awkward that in the browser, the only way to really get it is to run in memory in the main thread. What this architecture entails for us is basically that we need to try really, really hard to not have slow database queries. Because in a web app, if you have a slow database query on the back end, you just get a spinner. In this app, if something is slow, the entire browser just seizes up. And it's like a game janking or something, right? So we have to be really disciplined. And it remains to be seen, are we going to be able to keep it running smoothly, or are we going to have to find ways to offload more work off the UI thread? We'll have to see. But so far, as you saw in that demo, we've been able to keep things pretty smooth just through a lot of hard work, basically. Also memory usage. So you have to load the database into memory. Arguably, one of the most important things that databases are made to do is to manage the relationship between disk and memory. So you can just say, all my data's on disk. You have like a gigabyte of memory for cache. Good luck. And the database is smart. But we aren't really doing that. We're loading all the data in. So that means more memory usage. We're arguably not taking advantage of the database as much. So this is kind of a work in progress, but it's what we have working for us right now, and we found it to be the best option in the trade-off space. Another thing, so some of the demos I showed you just now were built on SQLite, but actually some of them weren't, and I want to talk a little bit about that. We found that SQLite was sometimes too slow to do the queries as fast as we wanted. SQLite's a really nice, it's a really fast database, but it's not built to return like really complicated multi-join queries always in under 10 milliseconds. That's just not, for arbitrarily large data. That's not realistic. And so we found that we were sort of running into those limits at times. One tech choice we've explored, so I've swapped out the bottom block here with this other database called SKDB. SKDB is an experimental, soon-to-be open-source database that's being developed by a company called Skip Labs. And you can think of it as essentially a really high-tech, sort of alien technology, complete re-implementation from the ground up of SQLite, but built for reactivity. So it has built-in primitives for doing things like registering SQL queries and then efficiently computing what's changed. And that's exactly the ingredient we need because we have all these queries that are changing a little bit, and we want to efficiently compute what's changed. And so we've also been experimenting with that database, which has given us some performance benefits in some places, and then it's caused other problems because it's way, way less mature than SQLite, right? And so we're still investigating that trade-off, but that's just another thing we've been exploring. All right, so now I guess I'll do my summary list of with the jungle metaphor, like the best, honey we found in the forest and the best quicksand to avoid or whatever. So first things first, I think SQLite we found is really nice for web apps in a lot of ways. There's been tremendous momentum over the past year around getting SQLite running in the browser, and the SQLite team is involved now, and there's just a lot of good stuff happening there. And so desktop and mobile apps have been using SQLite for a long, long time, and it's worth taking a look if you're building web apps with local persistence at what's going on in SQLite. And we love the relational model. It's for the kinds of apps I just showed, I think it's really like a good default choice. Another thing is starting with just a client code base. So we don't have any servers right now. And part of that, admittedly, is because we haven't gotten deep into the sync and multi-user stuff. But even so, it's sort of nice that we've been able to focus on the client experience and just not worry about this complicated thing yet, right? As I mentioned, everything persistent by default is awesome UX that respects your users' input. And so I highly recommend, even if you don't do anything else in this talk, figure out how to save all your users' stuff as they do it. It feels better than you might expect, I would say. Synchronous programming is really nice. I think we've just gotten too used to expecting asynchrony everywhere because we expect networks and we expect things to be on disk and so on. But the more you can avoid async, it just simplifies a lot of things in the programmer model. And finally, you saw those debugger views, right? And seeing your data in sort of a UI that you're used to, being able to download it and inspect it with specialized tools, and having really, really mature database tooling around all that stuff is just awesome. Things that are hard and aren't working as well, or that are just ongoing battles. Performance and efficiency. So again, the browser just often feels like an uphill battle to get to 60 FPS, and also efficiency in terms of, sometimes we run overtone for 20 minutes, and my laptop is burning hot, and I'm like, I wonder what that could be. And it's, we've been running a bunch of expensive data sync on the browser or something. And so part of what we're still navigating is how do you make apps that do a lot locally but don't eat up your battery, basically. There's one really kind of interesting and subtle point around when and how to sync data into the client. So I mentioned, the music collection that I showed you was taken from Spotify. And so then there's this question of when you log into Overtone for the first time and you enter your Spotify credentials, what happens? So one option is you sit there and you gradually see your entire Spotify collection appear over the course of a few minutes or something, and you just wait there. And during that time, you can't really do anything, right? And maybe you can click around on the data that's been loaded, but there's just this queue. And it turns out that is a really subpar user experience compared to most web apps don't have that. Right? You log in, and then you can just start doing stuff. And so something that Johannes has been experimenting with is flipping and reprioritizing the way that the data is pulled in, so that, for example, the user might start clicking on some of their playlists, and you want to sync that data first for that playlist they just clicked on, instead of queuing it all in some fixed order. And so one way I think you can see that is as sort of hybrids of the traditional web app, which only gives you data when you ask for it, and the sort of naive local first app, which just imports a dump truck before you can do anything, and finding kind of middle grounds between that. Third challenge is, just less polished tooling across the board in this ecosystem. For us specifically, we have really janky solutions to schema definitions and migrations. We have just a lot of issues with getting data from TypeScript objects into a relational database and back. And those are areas that are just paper cuts every day right now. And so if you're going the local first route, there are definitely sort of early adopter things that come up. But we feel confident that a lot of those are just solvable. And the last thing, SQL. I have a very love-hate relationship with SQL. Maybe you do too. It's really nice sometimes. It makes it very declarative to express relational queries. It also is terrible for UI development in many ways. It can't output trees, and most UIs are trees of data. Many front-end engineers are terrified of SQL and never want to touch it. And so if you want anyone, front-end savvy designer people working on your React components, it can be very intimidating to see the SQL directly. There are other reasons. But those are some of the biggest ones. That's part of why we've stuffed GraphQL in between. So actually, many of our things are a local GraphQL resolver running on top of SQL. That just adds more complexity to the stack, but so far it's served us OK. Do you have a question? Yeah.
what else would you try if you had 6 other engineers? Data log.
We've thought a lot about data log. I don't. So I mean, actually, I should call out. Nikki is here, and DataScript has had a lot of success as an in-browser database that uses data log as a query language. So there's some validation, I think, that could work. We've thought about sort of what would it look like to do like a SQL variant that was better suited for UIs, because actually producing trees and having better sort of schema modeling facilities are sort of the two big things, and maybe you could just bolt those on somehow. Maybe like, I don't know, Prisma could make a better thing for this use case. I don't know.
You could also maybe augment JSX, like kind of in an HTX kind of way. Do you know what I'm talking about? Like, so you split the query into, like the columns would be where they're rendered rather than in the root object.
Yeah.
There'd be some way that it could kind of suck up from a React children, like what the, you see what I'm saying?
That's a cool idea. I have not thought much about that, but I would love to talk more about it after. Yeah. And yeah, I guess if you have other ideas about what could replace SQL, like please let us know, because it just has drawbacks. So that's the basic experience report. That's all I wanted to share. I just wanted to show one more little thing that I thought was kind of would maybe plant some interesting idea seeds in your brains. So here's this is a video I took a long time ago from like Overtone V0 basically. And the idea we were exploring was, if you have this database on your client and you have this music app, what does having a local database give you for interoperability between different tools? So we have this thing where we drag in a generic SQL UI, and I'm going to edit the search box field in the database, and then I save it, and it gets entered into the original UI. And I can edit the sort order in the database, and it's going to resort the original UI when I save that. So what you're seeing is I've stored my UI state in a database, and then I edited the database directly from somewhere else, and that drives my entire UI. And if you think about it, because I put all the state in the database, anything you can do in this app, you can also do not just by clicking the buttons, but by scripting it through data, through this database, right? And because all the data is local, you can kind of permissionlessly do that through any tool you want. We haven't gone deep on exploring this, honestly, but I think it's an intriguing sort of thing to think about as one of the benefits of this stuff for opening up tools to be more malleable by end users. OK, that's all I got. There's an essay I wrote with Johannes and Nicholas and my PhD advisor at this URL. It's pretty old, but it has the basic ideas in more depth. And we're overdue for an update, so we'll probably publish more on this website at some point. And yeah, that's all I got. Thanks. Do we have time for questions? Or?
So I think we have time for some questions. Obviously, the entire point of this is also like then to have like even more questions over like some drinks later, etc. So hopefully you stick around and actually like that we get to chat about this. But if there are some questions already, like feel free to ask them.
I think you didn't mention how do you make SQL reactive, basically. How do you make SQL reactive? Yeah.
So what we do is we track semi-automatically which tables are affected by writes and which tables are used by reads. And then we sort of have a graph that when you write some data, it figures out, OK, you have 10 queries. Which ones need to rerun? And then we just go rerun those queries from scratch. So we do table granularity reactive tracking. The SKDB database that I mentioned that's not SQLite has native reactivity built in that's far more granular. So it can basically say, you added one new row. This query, we just need to go add that new row there. And that's like a much deeper form of reactivity that you have to kind of be deeper in the database to build. So those are the two things we do. With SQLite, we just rerun stuff.
But ideally, a database would just do that out of the box. This is why we're kind of looking at SKDB as well. And so, yeah, we get probably like in 5 years, we probably have like more databases that do so. Right now, we kind of like do a poor man's version of that ourselves. Yeah, maybe 2 more questions. You next.
How do you deal with data consistency? I mean, the database is on the client, so everybody can just break some data on if the database is broken. just what happened? Just
Yeah, so as I said, we haven't dealt much with these problems yet because we haven't gone deep into multi-user. I will say we've thought about it in theory a lot, and the biggest problem is that relational databases typically have very strong data integrity constraints, like foreign key constraints and uniqueness constraints, and data sync algorithms that are designed for offline availability and conflict-free stuff, like CRT algorithms, typically don't have any way of enforcing those constraints. Like, think about uniqueness. Like, if you and I both make the same user email, how is that going to be enforced? You have to come up with some solution there, right? So I think that's sort of the tricky tension to navigate, is strong data integrity constraints with concurrent edits from people offline. Yeah, we actually, if you go to the website at this URL, we wrote another essay on our website about some ideas for how to reconcile that tension, but that's the basic idea.
So yeah, a few more thoughts on that. So I think there's like broadly two kinds of collaboration that you want to do. I think one way that I had to that I realized, okay, this is also collaboration. It's collaboration with yourself, like your phone collaborating with your laptop. I would say you trust yourself a lot more than like random other strangers. So there you can probably already put other assumptions in place, and just like being authenticated is already enough to kind of and then it's a matter of like, once you're in, then it's a matter how you reconcile. And another way how you can think about it is like the same way as like the way how we use Git as developers. There's like, we're authenticated, that we can write to the repo. At some point, things are like a little bit like, okay, there's a conflict. The system could no longer really figure out like, hey, this is how I should deal with it. And then it's up to you, like, hey, so how do we need to talk to the other person? Like, hey, did you mean to do this or this? And then you like get together and then you fix it. And I think applying those mental models to applications is actually really nice. Some applications get this right and feels nice. Some applications get this terribly wrong. Maybe just remove your other thing, the conflicting thing altogether. You've lost days of work and you get really frustrated. So I think we're still exploring this, but the technology foundations are already pretty there. Like we have CRDTs, like YJS, for example, from Kevin. And so I think now it's basically just building the right user experiences around it, finding the right best practices. But there's certainly no silver bullet there. Yeah.
I don't know, for example, if you have twice the application with different version, with different schema,
Yeah.
and you try to just loop around,
Yeah.
I can imagine some explosion.
Maybe one more question, then we have a lightning talk, and then a break for way more questions. And yeah, I'll moderate that.
Hey, great talk, thank you. So for the personal apps that you just talked about, where you collaborate with your past self, have you considered syncing data to like a little client running on a phone or a laptop? Because when I've built these offline first apps before, I never know how much I can trust my IndexedDB or local storage to like actually persist. And especially in Safari, it might be gone in 8 days from now if I don't use it or whatnot. But if I had something running on my local network, it would be very fast. Is that like something on the roadmap, maybe?
Yeah, I would say so. I think definitely relying on just having a single device as the only place where your data is stored doesn't seem like the best idea, and so yeah, totally.
And Safari.
And so I think syncing to like a peer running in the cloud, another device that you have, all makes total sense. Yeah.
Yeah. If you have Safari questions, talk to Nathan in the back there. Like he knows all the bad parts about Safari.
I'll be curious later to hear more. Like Adam, people building local first apps that actually have dealt more with sync would probably have more interesting answers than that. But yeah.
Okay, cool. Thank you so much, Geoffrey. Yeah.
Thanks.